Okay, the lesson today is going to build on what we did last time with factoring trinomials. One thing that I want you to notice is the factoring learning target today is just that students will be able to factor a trinomial to solve. Hasn't changed at all from last time, however, they might look a little bit different today because when we talk about a is not equal to 1, there's a couple different things we're looking at. So remember that standard form, I'm going to write it off to the side, is where we have like ax squared plus bx plus c, and a represents this first coefficient. So if a is equal to 1, that means we have an expression or an equation that looks something like x squared plus 5x plus 6. Now we know how to factor that one based on our 2.5 lesson. We create two binomials. We split up the x. Everything is positive, so we know that we're going to have positive factors. And then we look at factors of 6, like 2 and 3, that will add to give us the middle term of 5, and we know that that would be 2 and 3. Now, notice if there was a number out front, like you see below here, so now I have like a 3, we often looked for a greatest common factor. Well, sometimes that number would factor out with the greatest common factor, however, it won't always. So now if I try and pull this one apart, I can't just say x and x because there's a 3x squared. So in order to get 3x squared, I know that this is 3x and this is x. Like that's what we're going to have to look at, is there's other values that could multiply. The one on the right, if we look at this example, just to get the first one, that could be 4x times x. Give me 4x squared, or it could actually be 2x and 2x. So there's additional options, and we have to account for that. And not only does it change the first term, but when you're foiling and you get your other two terms, it's also going to affect that middle term. So we have to follow a little bit different of a procedure. We just want to make sure that we take care of that front number and that we account for it as we're foiling. So we're going to use a method through this video called bottoms up method. So what it's going to do is it's going to move that front number sort of out of the way and allow you to use what you already know about factoring. So the steps are here on the left. I'm just going to walk through them. The first step is to make sure that the quadratic is written in standard form. So standard form again means that the x squared term is first, the x term is in the middle, and then the constant is there on the end. Then we look for a greatest common factor. Again, that will never change no matter how many times we're factoring. We always look for greatest common factor. There's not one in this case. There's not a number that divides out of 3 and -7 and 2. So we're going to jump to the next step. The next thing it says is multiply the leading coefficient. Now remember that's the number out front, that a value, by the constant term. So essentially what we're saying is we're taking this front number of 3 that's sort of like we said in the way, and we're multiplying it to the constant. So we're multiplying it to the back number. Notice when we do that, we get x squared out front because we moved that 3. We still have the -7x in the middle, but the 3 multiplied by the 2 to create a constant of 6. Once you do that, now this looks just like the kind we factored last class. So we create our two binomials here. We split up the x to x, and then we split up the 6. So we use factors of 6, in this case 6 and 1, and we can factor that, and we know, again, those are both negative, so that we get that -7 shown in that trinomial. The big thing on this one is you're not done. Notice if I were to stop right here, if that was my stopping point, if I go ahead and multiply that, I get x squared, -1x, -6x, and a +6. That does not give me the original equation I was looking for. So what's really important is that we need to remember we're not done. This is where we finish the bottoms up. We've got to take that number that we originally multiplied to the back, and you have to divide it back out of your factors. So we divide this by 3, we divide this by 3, and then we simplify if we can. So 6 divided by 3 is just 2, and 1/3 doesn't simplify. So this is where we go bottoms up. We take the bottom number of the fraction, the denominator, and he just gets slid right in front of that x. So notice at the end we have x minus 2 and a 3x minus 1. Now again, if I was checking my answer, notice if I FOIL at this point or distribute, I get 3x squared to start with. I get x times negative 1 is negative 1x. Negative 2 times 3x is negative 6x. And negative 2 times negative 1 is positive 2. Notice there we have 3x squared. We combine the middle terms to get negative 7x plus 2. This does give us what we wanted at the beginning. So again, the process is not super complicated. We just have to remember to factor out that piece that we multiply in. Okay, so let's see if we can walk through these steps. So looking at example B, again, I looked for a greatest common factor. There's nothing that divides out of 4 and 13 and 3. The first two have variables, the last one doesn't. So this one also does not have a greatest common factor. So we want to always make sure we're thinking about that. The next thing it says is to multiply the front number to the constant. So if I do that, that leaves me with x squared in the front. That 13x is still in the middle, and then 4 times 3 would give me 12 in the back. Then I factor this. So just like we practiced last class, we start with looking at this. Everything's positive, so I know that this is going to be x plus and x plus. Factors of 12 that add to 13, right? They have to combine. So factors of 12 would be like 2 and 6. That adds to 8. 12 and 1. That adds to 13, so we can use 12 and 1. Now again, this is where we finish the bottoms up. So we have x plus 12, and we have x plus 1, and we need to divide out the number that we multiplied in at the top. So we multiplied a 4 to the back with the 3. So we're going to divide out a 4. Again, when we do that, we just simplify. So this first one would be x plus, and 12 divided by 4 is 3. Here I have x plus 1/4 still. That doesn't simplify at all. So this is where I'm going to take the bottom number and I'm going to slide it right in front of that x. So my final answer would be x plus 3, and I would have 4x plus 1. Now there are so many different methods you can use for factoring. Essentially, the goal is to be able to, in the end, right, factor the trinomial. So this is just one method that we're going to use this year in practice. Just really, really important that we remember if we multiply a number to the back, that we divide it back out. Let's try another one. This one has a greatest common factor. So here's one example. If you want to look at this example, walks through the steps. I'm going to go through the same steps on example D. So first it says factor out a greatest common factor. Notice here all of these are divisible by 2, and that seems to be the biggest number we could divide out. So we're going to pull a 2 out to the front. Now don't lose that 2. It's got to stay there the whole time. If we divide out a 2, we end up getting 9n squared. We divide out a 2, we end up getting negative 9n. And divide a 2 from negative 8, we end up with negative 4. Now again, that 2 has to come along with us the whole time. So we just know that that 2 is going to come along, right, all the way to the end until I have my polynomial factored. However, notice you still have, even though we took out a greatest common factor, you still have a number here in front of your n squared. So we multiply that back to the constant. Okay, we're going to end up with n squared. The middle term stays the same, but 9 multiplied by negative 4 is negative 36. We then go ahead and factor that. So that's a trinomial that can be factored into a binomial. So we split up the n squared as n and n. Notice it's a negative 36 there, so we know that these are going to be different signs, one positive and one negative. Factors of 36 would be 9 and 4. They need to have a difference because they're different signs of the negative 9 in the middle. So those have a difference of 5. That doesn't work. 12 times 3. 12 minus 3 is a difference of 9. We want it to be a negative 9, so we're going to make the 12 negative. So we're going to put this in here, and we've got 12 here and a positive 3. Again, we're not done. We have to finish the bottoms up, so I'm going to write it down here really quick. You wouldn't necessarily need to rewrite this. I just want to show all the steps. So we would then divide out whatever we multiplied in. So notice you're not dividing out this 2. The 2 is still there. It's coming along for the ride. The 9 is what we multiplied back here, so we're going to divide out 9. Now when we do that, we get 2, and then notice these fractions can simplify. So 3/9 is the same thing as 1/3. We just divided 3 out of each piece. And 12/9 is the same thing as 4/3. Okay. Again, these are both fraction ones, so we take the bottom and we move it right in front of that n value. So in the end here, I would end up with 3n plus 1 and 3n minus 4. Okay, that would be factored. So we have a few more practice problems here. Again, maybe pause the video and try it out. Go through those steps, see if you can do it. And I'm just going to work through these rather quickly. And then if you want to kind of check your work on them, you can. So again, I'm just going to walk myself through the steps. I look for a greatest common factor. Looks to me like all of these numbers can be divided by 2. It looks like all of them can be divided by 4, which is even bigger. So I'm going to go with 4 and divide that out. If we divide out a 4, we get, lost that. We get 2m squared. 12 divided by 4 is 3m. And 80, or negative 80 divided by 4 would be a negative 20. Again, the 4 is going to come along for the ride, so sometimes I write it like this. The 4 is going to come along. I'm just going to write a big one. And I'm going to move the 2 to the back. So I'm going to get m squared plus 3m. 2 times negative 20 is negative 40. Once I have that, I am going to factor this trinomial. Now notice that big 4 at the front. I'm sure that's terrible notation, but it's just coming along for the ride. So the 4 is there. I'm going to split up my m and my m. It's a negative 40, so I know that these are going to be different signs. So one's negative, one's positive. And factors of 40, I shouldn't write it like that. Factors of 40 would be like 4 and 10. That does not have a difference of 3. So maybe it's going to be 8 and 5. Yeah, that has a difference of 3 if I do 8 minus 5. So I'm going to put 8 by the positive, 5 by the negative. Now again, even though we worked so hard and got that, we're not done. We need to divide out the number we multiplied in. So remember up here it was a 2. So we're going to divide out a 2 from each of those factors. And as I do that, I get m minus, that's still 5/2, and I get m plus 4. So again, we're going to take this bottom thing, value thing, and move it up to the front. So your 4 is still out front. We're going to move that 2 in front of the m. We got minus 5, and we've got m plus 4. On this middle example, you have a negative greatest common factor. So essentially, there's nothing that divides nicely into 9, 14, and 5, but we can definitely pull out the negative so that we're just dealing with x squared. Oh, lost my 9. 9x squared. If I divide out a negative, that makes it a positive 14x and a positive 5. Okay. Now again, the negative is going to keep coming, but that allows me to not have to worry about that front coefficient being negative. So again, I'm going to multiply the 9 to the back. So we're going to go x squared plus 14x. 9 times 5 gives me 45 there at the end. So then I factor. I'm going to create my two binomials. I'm going to have x and x. Thinking about factors of 45 would be, say, 9 and 5. Because they're positive, everything here is going to be positive. So I'm going to find something that adds to the middle term 14. Very good, that works. So we're going to use 9 and 5. Now again, we're not done because we're using bottoms up. So we need to divide back out the 9 that we multiplied to the back. So we divide out the 9 and we get negative x plus 9 divided by 9 is 1. And 5/9 doesn't simplify, so I'm going to move that bottoms up right there and we're going to get 9x plus 5. Guys, done. Last one on this one, again, it's in standard form. I look for a greatest common factor. It looks like all of these ones are divisible by 5. So we're going to go through and divide out a common factor of 5 to start with. So let's put the 5 out front. We're going to have 7n squared plus 15n plus 8. Again, that 5 is going to come along for the ride all the way, and we are going to start our bottoms up. So we've got a 7 here that we're going to multiply to the back. That gives me n squared plus 15n plus 56. Now factors of 56 so that we can factor this down, right? Notice everything's positive, so we know it's going to be an n plus and an n plus. So we've got to find factors that multiply to 56. So we could do 1 and 56. That doesn't add to 15. We could do 2, and if we take 56 and divide it by 2, that would be 2 and 28. Also doesn't add to 15. If we take 56 and divide it by 4, we get 4, and 14. That adds to 18. We're getting closer. So 56 divided by 7 and 8. 7 and 8, they add to 15. So we could use 7 and 8. From there, we then divide out whatever number we multiplied in, which in this case was that 7. So we're going to divide out the 7. We get n plus 1, and that doesn't simplify, so we slide that 7 up there, 7n plus 8. So our final answer, we have the 5 in front. We've got n plus 1 and 7n plus 8. Once we've practiced with a bunch of expressions, then we can go ahead and solve. So on these ones, you were just solving. Now again, the technique is the same as we've been doing on the last couple assignments. So we always make sure that we set it equal to 0. So we put all the terms on one side and put it in standard form. So notice on example 4, this 7 is on the side of its own. So we're going to move it over and subtract 7. When we do that, that's perfect because now it's equal to 0. And we have 2x squared minus 5x, and we'll sneak the negative 7 there at the end because he's the constant. We then follow all the same steps. We look for a greatest common factor. There's nothing that divides into 2, 5, and 7 nicely, so we start our bottoms up because there's a 2 out front, so we multiply it to the back. We end up with x squared minus 5x minus 14. Okay. We then factor that piece right there, and we get x and x. Notice it's a negative 14, so we know they're going to be different. And we're looking at factors of 14, so say 14 and 1 or 2 and 7, and they need to have a difference of 5. So 2 and 7 have a difference of 5, and we want a negative 5, so let's make the negative go with the 7. So we put a 7 and a 2 in here. Now notice I don't have this set equal to 0. And the reason I don't keep bringing the 0 down while I do my bottoms up is because this doesn't legitimately equal 0 at this point. Not until I actually go and divide out the bottom. If this did equal 0, then we could stop right here and solve. So we are not done. We do need to divide out that factor. So notice up at the beginning we multiplied a 2 back, so we want to divide the 2 out. Once we do that, we get x plus 1. This one doesn't divide out, so the 2 is going to slide up, so we get 2x minus 7. And now we've factored it, and it is equal to 0. So we bring that down, right, now that we're done completely with our bottoms-up method. Then we just state the solutions. So remember, we look at each piece separate. Here's our first piece. We say what plus 1 would be 0. Well, that would be a negative 1. And on this one, it's a little bit more challenging because it's going to be a fractional value. So we could just take 2x minus 7 and say what would make him be 0. Well, let's add the 7 over. Let's divide by 2. And it looks like 7 halves would work for that piece. Okay. Let's do another one here. So example 5, we've got 3x squared minus 6 equals 7x. Notice this guy right here is on the side by himself, so maybe let's move 7x over here. When I do that, I want to write it in standard form, so I'm not going to put negative 7x at the end. I'm going to put him in the middle. So I have my squared term, then subtract 7x, then I'm going to put the negative 6 and set that equal to 0. Again, we look for a greatest common factor. Nothing divides out of all 3 of those, so we start our bottoms up by multiplying the 3 to the back. We get x squared minus 7x minus 18 when we multiply the 3 and the negative 6. And I'm not going to write that. And then we go ahead and factor. So notice it's a negative 18, so we're going to have an x plus and an x minus. And we're looking at factors of 18 that have a difference of 7. So factors of 18 would be like 3 and 6, or 2 and 9. 3 and 6 subtract to 3, so it's not that one. 2 and 9, we could do that one. 2 minus 9 would give us that negative 7 that we want, so we're going to use a negative 9 and a positive 2. Again, we're not done. We divide out that 3 that we multiplied in the beginning. If it doesn't simplify, we move the bottom up. So we get 3x plus 2, and we get x minus 9 divided by 3 is 3, and now we can equal that to 0. So our solutions here would be x equals 3. And our solution here, again, you can set that equal to 0, subtract the 2 over. So we get a negative 2 on top, and then we would divide by that 3. Okay. Again, this last one. So we've got a negative 15, so let's add him to the left side. We get negative 21x. We add the 15 over here, which leaves nothing on the right side. We then look for a greatest common factor. All of these divide by 3. So if I pull out a 3, that's dividing that by 3. I get 2x squared. Divide the negative 21 by 3 and get negative 7x. Divide 15 by 3, and we end up with a 5 there. Now again, that 3 is going to come with us, right, this whole time for now. And then we go ahead and use bottoms up. So 2 multiplied to the back, we get x squared plus 7x. And in the back, oh, I don't know why that became a plus 7x. Definitely not. Minus 7x. 2 times 5 gives us 10. So we factor that. Again, that 10 is positive, so we know that these are going to be the same. But notice the negative on the 7 makes us understand those would both be negatives. So factors of 10 that are going to combine or add to 7 would be like 1 and 10 or 2 and 5. And remember, everything's negative on this one, so negative 2 minus 5, that looks like it would work to give us 7. And then we finish the bottoms up by dividing back out that 2 that we multiplied in. So we end up with x minus 1, and we move that 2 up and we get 2x minus 7. Again, that 3 is there, right? So I'm going to write that 3, and that's equal to 0. And then this one we're solving, so we could say x is equal to 1, because 1 minus 1 would be 0. And then here we've got x is equal to, again, you can set that whole little piece equal to 0. Add the 7 over, divide by 2, you'll end up with 7/2. In the end, it's just important that we understand the difference between factoring an expression and solving an equation. These ones you solved, right? You used factoring to help you, and then we were able to solve. Most of them that we practice, we're just going to practice with an expression. We finish. You can't solve that. It's not equal to anything. We just practice with our factoring, and then when we're asked to solve, we're going to go one step further and actually find those solutions. These tools allow us to move from form to form. So down here it says we use distribution, or in other words multiplying. When we want to move from factored form, oh, that says form, so I won't write that, to standard form. So if I'm going to write it in standard form, I go ahead and multiply it out. If I want to use factoring, that means it's in standard form, but I want to solve, so I move it into the factored form. Okay, we either multiply or we factor. Those are inverse operations. Again, work through this in practice. If you need to go back to the steps and just walk through those steps over and over and over again, those steps are there for a reason, and you have a written example and then plenty of worked examples. Okay.